Alright, so this could be our next notes in geometry. This is lesson 7.2, and we're going to be looking at something called similar polygons. And the thing we want to remember about this that similar initially does not mean congruent, okay? And it doesn't necessarily have to be the same size. And we can see here the rules. It says do not have to be the same size, even the same position or the same orientation. Now the last two, position and orientation, could be for congruent triangles. So you could have one triangle in one place in the coordinate plane and another one in a different position. But if they're the same size, they're congruent, right? But here we're talking about ones that don't even have to be the same size. They're similar, but not exactly the same, okay? And the only thing, and what makes them, or not the only thing, the things that make these polygons similar is that if they're different sizes, they're different positions, you just do some type of transformation. So you might do a rotation. If it's 180 degrees, you rotate 180 degrees, and it is the same if it's the same size. Or a dilation, so it's much smaller, you make it some kind of scale factor, you make it larger, and then it is the same, it's congruent. Or some type of reflection as well about an axis. Or any other type of transformation. It takes a similar polygon and then makes it congruent. The main thing here we're looking at is size and dilations. So what are some properties of these similar polygons? Well, it's the following. So similar polygons have two main things. They have corresponding angles that are congruent. So if we look at triangle ABCD and triangle WXYZ, we see angle A and angle W are congruent, angle B and angle X are congruent, angle C and angle Y are congruent, and angle Z and angle D are congruent. So we could say, based on that, we're halfway there to saying these are similar polygons. Now you see they're not the same size. Okay. The second part of this is corresponding sides are proportional. So whatever the proportion is that exists between each side, AB and WX should be the same proportion between BC and XY. And we'd see 15 divided by 5 is 3, and then 12 divided by 4 is 3. And then we did 21 divided by 7 is 3. And then 18 divided by 6 is 3. So we have a scale factor, it's called here, a scale factor of 3. Okay. So, and we could even go the other way. So the scale factor from this one to this is actually a third, right? So it's smaller, so it's 1/3 the size. We could also look at it the opposite way as being a scale factor of 1/3. Okay, and then because this proportion is true, we can say all of these sides have the same ratio. So if we took AB compared to WX, it would be equal to BC compared to XY, and so on. You can kind of see these. And this number that it comes out to be is just, it'll tell you the scale factor that exists between them. Okay, so that's kind of some of the properties. You can also want to remember, we should remember, that there's some things that we use for proofs that are also true with these similar polygons, and that's something, the reflexive property. So triangle ABC is congruent with triangle ABC. And if you remember, this kind of one ties into, like, let's say we have a triangle that has a bisector through it. Okay, and we know that we have, like, if we call this A, B, C, D, we know that if we went around this triangle here, 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 and this triangle here, here, and here, they share this side. That's a reflexive thing, and it's the same. So it has to be congruent. So we can figure that out with similar polygons as well. Okay. Then symmetric, this is really just saying if ABC is congruent with DEF, we can also say it the other way. DEF is also congruent with ABC. Okay. The one also transitive, and this comes from some of our other proofs that we did in triangles and such. Transitive says, so if ABC is congruent with DEF and DEF is congruent with XYZ, then ABC is also congruent with XYZ. Okay, those are those three properties. Keep them in mind, you'll be seeing them. Okay, so then one more thing we want to look at and we'll be done with the notes. This is perimeters of similar polygons. So if we know these polygons are similar, And here the rule says if two polygons are similar, then their perimeters are proportional to the scale factor between them. Okay, so if we have these triangles A, B, C, D, and J, K, L, M, okay, we can then take the perimeters, the outside, and when we add them all together on the top, ooh, lost something there. So if we add them all together on the top, we add them all together on the bottom, we're comparing them, the perimeters, that should be equal to the scale factor of any of the sides. So if we add these all together, and then we compare AB to JK, it should be the same. Okay, and that's called the perimeters of similar properties. And what we can realize that if we remember that the perimeters are similar, or they're equal to each other, the scale factor, then it can help us figure out something we might not know. Okay, so keep them in mind. Add these to your notebook, and we'll do some practice problems in class.